Hi everyone. So today we are going to be learning how to graph square root functions. So for example, f of x equals the square root of x, which is the parent function, which you should have seen and explored in your Desmos activity yesterday. So today we are going to continue talking about that, continue to talk about graphing these functions. Now, there are some similarities with graphing quadratics because they follow the same rules as far as transformations. But you have to think about what the square root means and what it represents and how we use it, because that's going to be important when we start making, for example, our table of values, and it's going to affect what numbers we can plug in for x. Because like I told you in class, in this unit, we're not using imaginary numbers. So we can't take the square root of negative numbers. So I want you to keep that in the back of your mind as I start going through the notes and kind of explaining everything. So let's do that now. Okay, I forgot to mention, since this is a video, please feel free to pause, rewind. Anytime you need to kind of gather your thoughts or go back and review something that I mentioned. So let's get learning. Okay guys, so if you have your notebook, I'd like you to open up to page 16, and you should have this blue little booklet where we talked about we started to talk about the second half of our parent functions. So remember, our parent functions are just the most basic form of our functions. We talked about the linear function, absolute value function, quadratic function, and how they all have different shapes. So now we are going to continue because now we are talking about the square root function. So that is going to be our next parent function. So on our second flap here, we are going to write square root. So this is the next function we will be talking about, and the next function we will be graphing. If at any time you need to pause or rewind this video, or even just jot down some questions for me, please feel free to do that. Okay, so I'm going to open up this flap, and it's a little bit off because of the copier. So again, just filling this in here, and actually I'm going to switch to my pencil. So we are talking about the square root family. The parent function for the square root family. Sorry, that was off camera. So remember, f of x is the same as saying y equals. So if you want to replace f of x with a y, you can. But the parent function that we are talking about is the square root of x. So we are going to be graphing this function. In order to graph, we need to make a table of values. So actually here you need to think about what the square root represents, and what kinds of numbers can we take the square root of, because we don't really want to have to work with decimals. So we want to work with taking the square root of perfect squares. Now in this unit, I does not exist. So you don't have to worry about I, but that also means that we won't be able to take the square root of negative numbers. So I want you to kind of picture in your head that you're sitting in my room, and I want you to imagine the chart that I have above the smartboard that has all the perfect squares on it. So I want you to imagine that chart, and those are the numbers we are going to be plugging in for x, because those are our perfect squares. So our lowest perfect square, it's actually not on that list in my room, but it is 0. So if you plug in 0 for x, the square root of 0 is 0. Our next perfect square is 1. The square root of 1 is 1. All right, so far so good, right? Now, here's the thing, our next perfect square, it's not 2 or 3. We're gonna plug in 4. Again, because we don't really want to have to work with decimals here. The square root of 4 gives us a nice even whole number, 2. So again, imagining that chart in my room, thinking about our perfect squares, our next perfect square is 9. The square root of 9 is 3. Okay, if we kept going, we would have 16, 25, 36. Those are our next perfect squares. This would give us 4, 5, and 6 if you took the square root of each of those. Now here's the thing though, our graph only goes up to 10 and we don't really want to scale if we don't have to, so I'm not going to include these last 3 ordered pairs on this graph. You can if you want to, but I think these 4 will be fine. It'll be sufficient for our graph. So I'm going to go ahead and graph these first 4 ordered pairs. So 0, 0, 1, 1, 4, 2, and 9, 3. Now again, this graph is not going to be the same shape as any of our other graphs. So notice it's not going to be a U shape. It's not a straight line. It's not a V shape. It's not a curve. This graph is actually a ray because it starts at this point and continues going forever in the other direction. You do not want to extend this the other way. So on these graphs, we only have one arrow. And remember, that's because, so for this equation, we can't plug in negative numbers. So we can't have a -1 and -2 under the square root. So we can't extend the graph that way to represent that. This is actually what we call our end point. You could also think about it as a starting point. And this will change depending on what transformations you make to this equation. So remember, this graph, right, it could move to the left, to the right, could move up or down, it could be reflected, so it could face down. It all depends on what your equation looks like. So that brings us to our domain and range. The domain is talking about our possible x values. Range is talking about your possible y values. So for our x values, we're kind of going back to what I was talking about before. Remember, we can't take the square root of negatives in this case. So the lowest our graph is going is 0. And then it keeps going to the right forever. So for our domain, we can write that as x is greater than or equal to 0. Similarly for the y values. So the lowest y value is 0. So for our range, y is greater than or equal to 0. Again, this will change depending on that endpoint. Our x and y intercept are both 0, 0. That's where it touches the x and y axis. Here, this is just a coincidence that it's the same as the endpoint. That is not always true. It just works out that way because this is our parent function. If you look back at our other examples, you'll notice that was similar. Relative minimum. So remember, minimum is the lowest the graph can go, maximum is the highest. Here, our relative minimum is our endpoint. So that would be 0, 0. But it keeps going up forever and ever, so we don't actually have a specific maximum. So that's not applicable. Okay, so here we have our parent function of the square root family. If you need to at this time, pause, rewind, write down any questions, please do that. And then we are going to go through our other page. Okay, so we just talked about the parent function of the square root family. So now we are going to look at how we can make transformations to that equation. So I would like you to reference the page on transformations of functions in your notebook. I'll put that page on the screen right now. And you're going to notice that it's very similar to what we have on your note sheet. And it's actually very similar to vertex form of quadratics. The main difference here is that instead of parentheses, we have the radical symbol. And notice attached to this radical symbol is this little n here. N represents the index of the radical. And this actually tells us the shape of the graph. Since we're just working with the square root function, for our examples, n is going to equal 2, because when the index isn't written, it's automatically 2. So the shape of our graphs will be the same as what I showed you with the parent function. It'll be a curve that starts at one point and then continues on in one direction. So that brings us to our A value. A tells us the same exact thing as it did with quadratics and all the other functions that we've talked about. So if A is greater than 1, the graph will have a vertical stretch. So in this case, the curve will start to increase more quickly, so it'll have kind of more of an arch to it. If A is between 0 and 1, so this is when we have a fraction, that represents a vertical compression. So that means the curve would be flatter. A also tells us if it is negative, that represents a reflection over the x-axis. So again, this is the same information that we had talked about before when we talked about transformations and when we talked about vertex form of quadratics. Now we are just going to apply that to the square root function. So that brings us to our h value. So remember, h tells you if you're moving to the left or to the right, but here's where you don't want to get tricked, right? If you are subtracting, that means you are moving to the right. And if you are adding, that means you are moving to the left. H also gives us the x value of our endpoint. So I'll talk about that a little bit more in a second. Let's finish up with K. So K tells you if you're moving up or down. If you are adding, or if K is positive, you're moving up. If you're subtracting, you're moving down. K tells us the y value of our endpoint. So let me sum that up right here. So make a little bubble. HK gives us our endpoint. So remember, you never want to go past your endpoint, so these graphs should not have two arrows on them. This is the point where it starts and stops, kind of. Okay, so we have an example down here, and let's just take a look at the equation first and kind of notice the different transformations that are happening. And that can help you predict what the graph is going to look like before we start actually making our table of values. So looking at this equation, let's look at our A value. So here our A value is -2. So it's negative. So that means that we are going to have a reflection over the x-axis. So that means instead of the curve going up, this curve will actually be going down. So that's what the negative tells us. The 2 is separate. That tells us that we are also going to have a vertical stretch. So the curve will be a little bit more expanded vertically. Under here, let's make note of our H value. So here we are adding 3. So that means we would be going left 3 on our graph. So for our endpoint, it would be at -3 for the x value. And then going back to the equation, looking at our k value is -4 or -4, so that means we're going down. So our y value for our endpoint would be -4. So remember, H and K give you your endpoint for the graph. So this gives us also a starting point for our table of values. So I'm actually going to plot that point. So -3, -4. And then I'm going to set up the table of values. So now I'm just gonna squeeze it on the left side over here. So I'm gonna make my 3 columns. In the middle column, I'm going to put our equation. Now, you might be thinking that, okay, so -3, -4 is our endpoint. So here, this is our x value of our endpoint, but Ms. Rock, we can't plug in negatives under the square root. So how the heck are we going to do this? So actually notice what happens when you plug in -3. So that's our endpoint. Also think about it as your starting point for the table. So here, I'm going to start with -3 as our x value. So again, going back to that endpoint. Look what happens when we plug in -3. So I'm just going to copy down this equation, plugging in -3 for x. So here, let's take a second, just talk about order of operations. Order of operations says we do parentheses first. Well, parentheses also means grouping symbols. The square root is considered a grouping symbol. So you have to perform whatever operations are under the square root first before you can continue. So we have to combine -3 plus 3 first before we do any other operations. Well, -3 plus 3 gives us 0. And remember, going back to our parent function, 0 is our smallest perfect square. So notice how that works out. So the square root of 0 is 0. Now continuing with the continuing with the order of operations. So 0 times -2, remember multiplication is in between here, multiplication comes next. 0 times -2 is 0. So 0 minus 4. So notice we get our y value of our endpoint. And that should happen, right? Those should match up. Now the question is, Okay, what number do I plug in next for x? Now, this doesn't match up with our parent function, okay? Because if we plug in perfect squares, it's not going to work out with what we have under the square root. So really, you have to think about what you have under the square root and how is that going to give you a perfect square. So your thought process should be, what number, when I add 3 to it, will give us our next perfect square? So here, right, we're not really sure what number we're plugging in yet. You need a number that when you add 3 is going to give you our next perfect square. So if we're going in order, after 0, our next perfect square is 1. So what number, when you add 3 to it, gives you 1? And it is -2. Another way you could think about it, 1 minus 3. So if we're doing the inverse operation, 1 minus 3 gives us -2. Because the goal here, since we don't want to work with decimals, is that under the square root, we need perfect squares. So you have to think about what operations are happening under the square root. So again, just to repeat that, we had the square root of 0. 0 is our first perfect square. Then we want to get our next perfect square, which is 1. So you have to think about what number, when you add 3 to it, will give you 1, because you need to be able to take the square root of this. So I'm just going to bring down the rest of the equation. This is probably one of the harder concepts about this topic, is figuring out what numbers you're plugging in for x. And I'll go through that again when we plug in our next number. So let's simplify this first. Order of operations. So -2 plus 3 is 1. Square root of 1 is 1. 1 times -2 is -2. -2 minus 4 is -6. Okay. And you know what? Let me just draw lines to separate our rows. So question is, what number are we going to plug in next? Well, what's our next perfect square, right? We have 0, we have 1. Our next perfect square is 4. So what number, when you add 3 to it, will give you 4? So we're going to plug in 1 as our next x value. I'm just bringing down the rest of the equation, our a and our k value, just to complete it. Okay, again, so 1 plus 3 gives us 4. 4 is the perfect square. That's what we want. Square root of 4 is 2. 2 times -2 is -4. -4 minus 4 is -8. Okay, let's do one more row in our table. And again, if anything is confusing you, please jot down questions and let me know. Okay, just to reiterate, so we had square root of 0, we got the square root of 1, we got the square root of 4. Our next perfect square is 9. So now we have to ask ourselves, what number, when we add 3 to it, will give us 9? So you should be thinking right now, 6. So 6 is our next x value that we're going to plug in. And again, just filling in the rest of the equation. Order of operations, so 6 plus 3 gives us 9. Square root of 9 is 3. 3 times -2 is -6. -6 minus 4 is -10. Here, we're going to stop. 4 points is enough for these graphs. And if we kept going, we would be going off the graph. So we are going to stop here, and now we could start plotting. Now guys, as we're plotting, you should be noticing how this graph will match up with the transformations we talked about before. So when we plot these points, you should notice that this graph will be a reflection. It won't be going up. This graph will be going down. You should notice how the endpoint moved over. We already have the endpoint. So let's go ahead and graph the rest of it, and you could see what happens. Okay, -2, -6, 1, -8, 6, -10. So again, this is going down because of this negative. It is a reflection. Remember, this is your endpoint. We are not going past your endpoint. Please do not draw an arrow in this direction. We are going to connect these points going down, and it's going to continue down forever in this direction. Now, this is going to affect your domain and range, and that will be the next thing that we talk about. Going back to the transformations for a second though, so we talked about how the negative affects the direction. It's going down instead of going up. The 2 made this a little bit of a steeper of a curve. Okay, it's not as flat as the parent function was. H and K moved our endpoint and the whole graph over and down. So now let's talk about the domain and range. So again, domain represents our X values. So X values, you want to think about how far to the left are you going, how far to the right are you going. The lowest X value that we can have is that endpoint, -3. We're never going to go past -3. So -3 is the lowest we can go, and then we just keep getting higher and higher as we move to the right. So as you're moving to the right, these X values are increasing. So here, our domain can be written as X is greater than or equal to -3. In interval notation, that would be -3, infinity. Our range. Here, our range is affected not only by our endpoint, it's also affected because of that reflection that we had. So notice instead of the Y values going up, these Y values are going down. The highest Y value is where our endpoint is at -4. And then our Y values just keep decreasing. So here, Y is less than or equal to -4. So this is the highest it goes, and then it just keeps going lower. In interval notation, so remember, interval notation is written lowest to highest. Here, the lowest Y value is at -infinity. The highest Y value, sorry, I almost knocked the camera over. The highest Y value is at -4. Again, these numbers should match your H value and respectively your K value. So these two numbers should match up with your endpoint. Okay, so that is graphing square root functions. So just to sum up a few things. So square root functions are a curve, either going up or going down, that have an endpoint and then continue on in the other direction forever and ever. So again, these graphs should have one arrow, and then just a point at the other end. So not two arrows, not continuing on in the other direction. Domain and range is related to that endpoint. So that H and K value, which again is the same transformations that we've talked about before in the past, and also going back to vertex form of quadratics that you just reviewed last week. When you're making your table, you are plugging in numbers for x that will give you a perfect square under the square root. So you have to think about what operation is happening under the square root and use that to see how that will give you a perfect square. So again, our perfect squares, our lowest perfect square is 0. And then in order, we go 1, 4, 9, 16, 25, 36, 49, etc. But remember, for these graphs, you only need 4 points, and that should be sufficient to give you that curve. So I hope this worked out. I hope I was effectively able to teach you this lesson. Please, please, please stay in touch. Let me know if you have any questions. And I really, really hope I'll be able to see you guys again soon. And I miss you.